Alright, so today we're going to be setting up a GRS 2A circuit controller with drag contacts. And what that means is we don't have the second drum on the back half to where the snap contacts were. This is the drum or circuit controller frame that was shown in the previous video with the loose lug. I went ahead and blasted it, and now we're going to put it together. And obviously without the back half of the drum, I only have the front half. This is a viable way of doing it. I've seen several 2As that have come out of service set up like this. If you haven't seen my previous video, I set up one of these circuit controllers with the second drum and snap contacts on the back. If you haven't watched that, I recommend starting with that one because I'm going to talk assuming that you've seen that one, but I will try and refrain from doing that. Alright, so how these go together is there is a shaft that goes through here. You have two oil ports. That's commonly known. It's where you can, when you oil the Semaphore with Semaphore oil, you can oil it there. This pin is tapered and will only go in and out one way. You have a locking screw. How I always set these up is the gear facing away from me. Basically, if this wood screw is pointed towards you, well, I can't say that. Who knows how yours is configured. But you want the gear facing away. And that's it. This is the only part of the circuit controller that we're going to be assembling today. And we're going to be assembling it to go to 3 positions. It is possible, it's just a little bit more finicky. They were definitely like this as came out of service. I've actually seen high voltage motors that were wired like this, specifically at Grand Central Terminal in New York City. I have 4 posts, 1 for each hold, and then 1 for each advancing position. So this will be 45, 90, this will be 45 hold, this will be 90 hold. If I were smart, I would put a space between here. I have this on backwards, but I already have the studs in there, so I'm just going to roll with that. Something that comes up quite a bit is the paint color for this. It was actually discussed just the other day. It looks like the original dark Glipdol is a close match to this, if not a perfect match. And then I use PPG Shopline Madura Red with a product code of 51024. So the segments I'm going to be using today are about 1 13/16. And I'm going to be using those for both the 45, 13/16. I'm going to be using that for both 45 and 90 advance. And then my holds, 1 1/4 inches. I don't know if that's the correct way to measure them. You can reference documentation, either the catalogs if you have fortunate enough to have a set, or they are on RR Signal Pix, P-I-X, just Google it, .com, Zach Gillingham's website. I printed stuff out. Excellent stuff, and that way you don't have to worry about ruining your originals. So let's get our gear orientation. So the gear orientation here, I've already marked it. That's what you want. You want it actually, so that way there's at least a couple teeth on the center position that are meshing. Then we want to put this dead in the middle. Get a wood screw. These are brass wood screws if you're missing them. Alright, so it's going to be 45, this will be 90. That's cleared there, right there. And what I'm banking on here is these fingers have about, let's see, about 3/8 of an adjustment. So these fingers have 3/8 of an adjustment, so I can stagger those on the drum, even though these, well, no, it's not on there. So it looks like there's going to be a break in continuity because there's a little bit of gap there, but I'll be able to make up for that with the adjustment in the fingers. Now, if this video is losing you a little bit, because I'm just going right for a quick assembly, I recommend watching the first one. The first one, I did get a couple people reach out to me with some critiques. I'm not a video maker at all. I left every bit of the, I guess you would call it bloopers in there. So you can see that how much of a, how much fiddling around goes into making one of these controllers work. Even though you can lay one out pretty easily on paper, by the time you get in the signal, you got a, a quarter of an inch here or an eighth of an inch here could be 10 degrees on the signal. So you got to fiddle with it quite a bit. All right, then put our holds in. So this is our 45 hold. This would be it right here. All right, so I goofed on the placement of this. I actually had a 2/4 down, so there's going to be a little bit of an overlap. Try that. All right, so just like the previous video, we're going to want to tie terminals together. We're going to want to tie our holds together. If you're looking for plates like these, or even a little maintainer wrench, check my eBay store. It's just my name, bverzi. I'll put a link to it in the description. I try to make this stuff available as cheaply as possible and whatever I can make, so that way people have the stuff. Speaking of which, I do have a few bottles of, or I try to keep a few bottles of Semaphore oil. These are already spoken for. But if you need Semaphore oil, please send me an email. I will try and get you accommodated. It's important to use oil on your Semaphores because it's an electrical inhibiting oil and it won't damage your windings. I know people were using transmission fluid. That's not what you want to use. Transmission fluid is a solvent-based oil that suspends everything inside of it, and it'll eat right through those. So what a winding is it's electrical wire with a varnish on it. And so basically any oil that'll eat through varnish, congratulations, you've just smoked your signal. That's binding up. So let's see here. This would be our 45 hold. It's right there. 45 shut down. That might be an issue. We might have to adjust this up. So we want the 45 to shut down when it's holding. So let's pull that to there. All right. And 90 is nowhere near engaged. So the 90 segment's going to have to move up. All right, so that's 45 shut down, 90 pickup, 90 hold, 90 shut down, and we're holding. Cool. We want to tie the advancing contacts together, 45 and 90, and you'll see why when I put it on the signal, or if you've already seen the previous video, you already know. So it's basically has to do with how it advances out of position. So you can just supply power up here on the top of these terminals. All right, and then we want to tie these top terminals together for the corresponding hold contacts. Made up these little whips already. This is made out of Okanite 16 gauge. You want to put washer, your wire, then your washer, and then your nut. I think it's a cardinal rule. Matters not how fast the guy with the wrench in his hand is moving. You always could do it faster. Or at least that's how I think. I'm very impatient. Alright, so what these little wrenches are for is when you're in situations where you have a double nutted deal, to where it's thinner than the wrench, or thinner than the nut, so you can come in with another wrench and take the double nut off. Handy as hell to have. Tom Guile gave me this one. Thank you, Tom. I'm having 50 of those made, so keep an eye out for those if you need them. And also, cover it again, you want to put some Semaphore oil in those holes when you have the opportunity. Alright, I will get this installed in the signal and then I'll bring you back. Alright, this benchtop power supply, I'll link down in the description. 10 volts, 3 amps. Alright, so we gotta hook the motor to the controller. This is actually the second time I have to film this because the first time I wired it incorrectly, making the common mistake of wiring both the hold coil wires together. That's not what you want. Negative on the common. This is the common post. This is bottom right coming out of the hold coil. These two are the hold coils together. This is the high amperage one. This coming straight up out of the motor is motor power. Motor power and high amperage coil wire need to be wired together, so that way as the motor advances into position to where the hold segment is, the high amperage coil will fall away as the motor shuts down. And you would normally want to do washer between each one of those, so go washer, then one wire, then a washer, then another wire, washer, then nut. I'm not doing that because this is coming apart after I'm done filming this. I'm not using this controller for anything. I'm just using this for demonstration purposes in case anybody is trying to put a motor together and they don't have a circuit controller with snap contacts. Snap contacts break. They were thrown away over the years. I've seen signals come out of service that this is all they had out of Grand Central Terminal. Majority of contacts on these circuit controllers were to communicate with other stuff. It wasn't all just to make the signal move. Alright, so green is negative. We're going to give it positive, take it up to 45. And you can't see the draw there. But you can see it's drawn 0.02, what is that, 0.012 amps. That's what you want to see. You want to see that power drop away. Alright, so let's go to 90. Kill the power, and it should buffer on the way back down. That's what you want to see. If you're wiring one of these up with a switch in line, you need to use a 2-pole switch. So that way you can kill both legs of power to insulate the signal so it'll create resistance as it drops and buffer the drop. If you just kill one leg of it, here, I'll bring it back up to 45. Actually, I'll bring it all the way up for you. Let's go 90. So then, let's say, what would this be, positive? If I just kill the positive circuit, so it only loses one leg, it's just going to ground out through the neutral and freewheel because there's no resistance. And I'll get you close up. Alright, and then here's a close-up of the circuit controller for anybody's reference. 90. And it's not perfect. If you really wanted to, you can fiddle with the fingers. There's 3/8 inch of play to where I could get this to, it's like at 89 degrees right now. So you could move it one tooth over on the hold, or actually you'd need to do both, because while I still have space on the hold, I don't have motor power, so I need to bring the motor power up. There's all sorts of little fiddling you can do to make it perfect. I'm not doing that. Just want to demonstrate how to get even to this point. From here you should have the gist of where to go.